Great. So hello, everyone. Welcome to the Transnational Asia Speaker Series hosted by the Chow Center. And just really quick special thanks to Heijin, Amber, and Haehoon for making this possible. And you've all been so heroic in all of your efforts in organizing the series. Thank you also to Lisa Balabanlanar for supporting all the creative and new scholarship that's been happening through the Chow Center. My name is Lan Lee. I am a historian of science and medicine, and it is my very, very great pleasure to introduce you to Dr. Anthony Acciavatti, and he will be speaking to us on the Himalayas, the Great Sediment Sorting Machine. Dr. Acciavatti is the Daniel Rose Visiting Assistant Professor in Urban Studies at Yale. And in the years that I've known Anthony, I have taken great inspiration from him as a researcher and as a teacher. And I've watched him creatively generate new knowledge, new ideas, and new questions at the intersection of architecture and the history of science and technology. So Anthony was trained in architecture at the Rhode Island School of Design and at Harvard University. And he was also trained in the history of science at Princeton and was a Fulbright scholar in the Department of Geography and Town and Country Planning at the University of Allahabad. So his recent book, The Ganges Waters Machine, Designing New India's Ancient River, is the first comprehensive mapping and environmental history of the Ganges River Basin in over half a century. And in 2006, the book was awarded the John Brinkerhoff Jackson Book Prize. And whenever I share this book with my students who are interested in design and environment and in the subaltern, there's always like the sharp intake of breath when they see Anthony's book and they realize what's actually possible through interdisciplinary humanistic inquiry. It's also a really beautiful book to have in your living room. Anthony's current book, he's working on a manuscript called Republic of Villages, which looks at the histories of science and design in South Asia since the late 19th century. And so today, his talk, The Himalayas and the Great Sediment Sorting Machine, challenges us with a basic question of methodology, which is how and why using the wrong thing for the right reasons or for the right purpose, such as using a digital camera, packaging tape, tube socks, GPS units, PVC pipes, and the magic wand in Photoshop, has allowed Dr. Acciavatti to understand how the billions of tons of silt that is shed annually from the Himalayas are sorted and distributed in a way that shapes agriculture and groundwater resources, as well as dwelling and construction practices across South Asia and Southeast Asia. So Anthony's digital and material improvisation has shaped his ethnographic survey of soils and silt that's offered this narration of the choreography of monsoons and of the Himalayas. So please join me in welcoming Dr. Anthony Acciavatti. Anthony, thank you so much for joining us, and please take it away.
Thank you, Professor Lee, for that incredibly kind introduction. It's an honor to be with all of you today, here to share the work. And I have to say that having been in academia for some time now, the work that Professor Lee has been doing is truly an inspiration to me. So it means a great deal for someone who I look up to, like Professor Lee, to say such kind words about my work. So I'm extremely appreciative. And I'm very thankful too, not only for the invitation from Professor Lee, but also to Heijin, Haehoon, Amber, and Beverly for all of their help with respect to organizing this. And I have so many things to say thanks for, but if there's one small regret, as I shared with Professor Lee, it's that I've actually never been to Houston, and I was so hoping I might get to finally do it. And you'll probably understand why, given the work that I'll share with you today, why I'm so interested in Houston, but hopefully one day. But nonetheless, it's really wonderful and a great honor to be with all of you here today. As Professor Lee mentioned to you, I'll be sharing work that's from my book, Ganges Water Machine, and also, I would say, kind of clandestinely part of my third book that I've been working on as well. Well, I always like to begin with this image, and I love that it says the Himalayas really big above it, because this in some ways couldn't seem further away from the Himalayas in terms of it as a mountain range, and I'll explain why that's important throughout the talk, and this image will come up again. But I'll begin very kind of succinctly, I suppose, at first, which is to say, this is a view of the Himalayas, or what's oftentimes referred to as the third pole. Here we're over the Bay of Bengal. This is a satellite image from NASA's Goddard Space Flight Center. And you can see that huge geological wall that is the Himalayas. And kind of a very pocket history, or let's say YouTube-friendly story of how this geological wall gets formed is, say, for example, right, the continents are starting to break apart. You can see in this YouTube video, Digital Reading the Formation of the Himalayas, how the subcontinent runs almost like a deep impact into Asia, and voila, we have the Himalayas. The Himalayas then have been described, and of course there's many different kind of outer, inner Hindu Kush versus the basins, but suffice it to say that it's referred to oftentimes in the late 20th and now in the 21st century as being one of the third poles of the Earth, meaning that it has the third largest concentration of fresh water on the planet, third only to the Antarctica and the Arctic. And it doesn't just sit obviously within one nation state. Today it sits in quite a few, as you can imagine from seeing this image here that's talking about the Hindu Kush Himalayan region in green, and then the kind of turquoise downstream river basins. And then you can see those lines passing through the cyan, which are supposed to be the channels of the rivers. The area that I'm going to speak about then today really focuses on a very small portion of this very large sediment sorting machine, which is the Ganges River Basin. And it's, when I say sediment sorting machine, two ecologists by the name of J. David Allen and Maria Castillo, two ecologists, refer to rivers as being a kind of sediment sorting machine. And I'll speak about that especially with respect to the Ganges and to a lesser extent with the Brahmaputra. And I like this drawing quite a bit from 2019 of a water availability in the third pole, because what it shows very nicely, I think, is, of course, we get a sense of the larger geopolitical stakes of this area and all of the different river basins, the Yellow River Basin in the farther east, all the way to the Indus, the Ganges, but we also see the monsoons coming and exiting through this area as well, which plays such an important role. And I'll talk more about that in just a little bit. So this is really the last image that I'll show you that's really not made by me in this presentation, with a few exceptions, historical ones mostly. But I think this is a helpful image of showing you the Ganges River Basin, which of course is mostly in India, but it's also in Nepal, Bangladesh. So it's within a larger trans-regional, trans-Asia area. And what I hope to share with you today, and it may seem extremely straightforward and even flat, but it is to say that while I have never been to Nepal, I have traversed Nepal. And I'll explain to you why, because of the way in which sediment is shed annually from the Himalayas as part of this larger sediment sorting machine. So this book, then, Ganges Water Machine, really looks at a very small portion of this larger Himalayan sediment sorting machine. It's a 400-page book. As one dear friend says, it reads like 380 pages, so I won't possibly try to shoehorn into this talk all of that aspect of the project, but suffice it to say that it begins with understanding the different cultural layers of the landscape, its sacred geography, from the Ramayana to the history of the Mughal Empire operating there, the East India Company, and the Raj, and then ultimately also independent India. And it also then does a kind of series of studies of large scale and small scale infrastructure that have come to define this machine. And I'll speak more about that in a little bit. But the big thesis of the book is really, how do you start to look at the layers of this watershed, its biophysical, its political, its sacred geographies, and their entanglements with one another. And so I oftentimes get asked, well, why would you write a book to visualize this basin in terms of its layers? And the kind of made-for-TV answer, which I'm really bad at, which is why I have to write it out, is that because words and numbers fail to capture the dynamism and deep rhythms of this monsoonal landscape. And so to that end, I'm going to really focus then on this incredible amount of sediment that passes through this area, that's this laden river basin of silt and sediment, where really one sticks your arm into this and you can't, it loses visibility within a few inches, within 10 centimeters. You can no longer see it because swirling throughout the river basin, I would argue, is the suspended matter and the tectonic crumbs of deep geological time. And so the different sedimentary debris found within the river basin is a consequence of geometry and geology. And I would argue it's best drawn in vertical section, which is to say, I'm looking at it almost from the point of view of stratigraphy. Stratigraphy, right, is the study of the layers or strata of rock. And when say a geoscientist might look at this, this starts to be buzzing full of what they would call sedimentary signals, meaning that there's a kind of process of layering that's happening here. And what I'm looking at is not just the kind of geological, let's say almost non-human, but how does that intersect also with the human and non-human in terms of the mineral, the vegetal, and the animal kingdoms in this basin? So how is co-authorship taking place here? And so I show you these two photographs of how I try to look at the strata of the larger basin. And of course, this silt, which is in that same area that I began the photograph from of Allahabad, or what's known today as Prayagraj, much of this silt and sediment actually is shed from present-day Nepal. And to that end, then, I'll really focus on two portions of this Ganges River water machine, which is the city of Allahabad, Prayagraj, and then a series of transects or sections through it. And I'll explain more of this in the coming slides. But suffice it to say, I'll be relying a lot on visual imagery in order to narrate the story of how this river basin became one of the most hyper-engineered landscapes on the planet, and why looking at sediment can draw into focus so many other aspects of lived experience and aspects of urban form, as well as urbanity, or how people live within this basin. So that means then I'm not going to tell you, for example, about James Rennell's text that was read before the Royal Society in 1781 by Joseph Banks, where he speaks and writes quite eloquently about the vapors wafted from the Bay of Bengal that produce that firewater cocktail known as the monsoons. Yet when it comes to making a map, Rennell makes a map like this, because in short, colonialism and imperialism requires a kind of flattening of space. So here we can see how rivers are rendered as two parallel lines, roads as a single line, towns as just a circle, which is very useful if you want to march an army or collect taxes. But in terms of talking about the dynamism that happens here, there's a kind of flattening of space that I want to resist, both in the descriptions that I give you, as well as in the images and drawings that I make. It also means that, for example, I won't talk to you about how Jules Verne wrote The Demon of Cawnpur in 1880, oftentimes referred to as the first steampunk novel, where a series of British and French engineers travel across the basin in a steam-powered steel elephant. Really quite beautiful descriptions of the electric charge that Verne talks about in terms of the basin, but yet even still, when having to do a map, it's again that kind of flattening of space we see on the right of the river basin as a set of just parallel lines that empty into that pochade set of lines or hatches that we see of the Gulf of Bengal to the right. It also means I can, for example, share with you how the Himalayas are understood, especially within Hinduism, as being these terrestrial sites that are imbued with celestial significance. These are what are known as yatra nakshas, or yatra maps, pilgrimage maps, that one finds all throughout the basin, especially in the upper Himalayas. This is just one of many that I collected, where you can see here all of these mandirs, or these temples within the larger Himalayas, yet you see none of the infrastructure like the Tari Dam, which is one of the largest dams on the planet that's very close to a major fault line. In the Himalayas, we see none of the infrastructure that's been put in place in order to reroute rivers. It also means that, for example, I won't get to tell you about how along the Ganges Canal, which is the longest canal system in the world, that we also find the major temples in the city of Hardwar, not along the river bed per se, but instead along the channel of the Canal, which was built by the East India Company, nor about, say, Ganga's descent from the Ramayana, where Ganga's descent is said to be so great that when she comes to earth, she would break the earth. So Lord Shiv, that you see to the right, the blue-throated god, offers to catch her or arrest her fall in his locks of hair, which I think is an incredibly compelling explanation of how we might start to think about the river basin, not as two parallel lines or squiggly lines running across it, but instead as like a mop of wet, saturated hair. So obviously, I'm not going to get to go into great detail about that. I assure you I do that in the book, but I won't do that today. It also means that I'm not going to do the kind of BBC News, Ganges, India's dying mother, right, where I show you this hazy image of a flyover of the British correspondent, right, coughing because of the smell that's coming from this nala or this open drain. Speaking about this being one of the most polluted rivers in the world, not because this isn't important, but because it's not what I'm going to focus on today. Nor am I going to talk to you then about the different kinds of almost bricolage or jugaad that people use to then develop methods of filtration of this water that you can find endless YouTube videos of. Even Tata has developed its Swatch Smart program to filter water. So we can see how big business, like the equivalent of like, Hyundai or Toyota, get involved, and even at the small scale of water filtration, or even what the development community loves of the lifesaver, right, of the intrepid trekker sipping out water that's supposed to be non-potable on one side and potable on the other side, this kind of technological fix. Or say of pouring supposedly polluted water, taking the condensated water out and making it drinkable. Because in all, I would say these technological fixes produce something akin to what you see here, which is literally a urinal standing by itself near one of the most sacred sites within all of Hinduism, where the Triveni Sangam, where the Ganga, the Jamuna, and then another river is said to meet the Saraswati. For me, the work that I have to do is to both try to understand these kinds of what some would call bottom-up processes, along with these very large top-down, highly centralized systems, to fly somewhere in the middle of where these two worlds kind of intersect. So the drawings that I'm going to share with you attempt to draw larger part-to-whole relationships between the river basin and those living within it, and its longer and shorter histories. So I'll primarily focus then where I did a lot of my field work to do this project, not the only place, but one of the most substantial, which is the state of UP that you can see here. UP is a fascinating place because it has over 200 million people living in an area half the size of California and produces close to 18% of India's food grains. The World Bank estimated that last year, the state probably reached 270 million people, right? So it's an incredibly densely populated area, but it's a kind of mosaic of agriculture and cities. The closest example I could give you in terms of the United States is that imagine it's like New Jersey, but on steroids, meaning that it's this kind of spreads and densities of human settlement as opposed to high concentrations. Of course, in some ways, you could almost argue it's a continuous city in this area because of the mixture of agriculture and human density, but it's a very particular kind of urbanization that's taken shape here. And this state has incredible amounts of hydrological infrastructure, from canals, systems that I mentioned to you before, to, of course, myriad rivers that are mostly fed from the Himalayas, but also from the Vindhya range, which is to the south, that I'll talk more about in just a bit. I'd like to always show this image here because this is the first spatialization and visualization of the 2011 census that was done in India. This was done by the Indian Institute of Human Settlements. And this is all of India, of course, but you can see that here is the Ganga River Basin. I hope you can get a sense of just how densely populated this is in terms of its very large villages all the way down to hamlets or smaller, just to give you a sense of how densely populated this area is. And of course, as I mentioned to you, it's not just that it's in India, it's of course also in Nepal, China, Bangladesh. And so it's obviously a transnational water body, though primarily in India in terms of its surface area, as we would define it. And oftentimes, trans-border discussions focus primarily on water as though it's a kind of plumbing system. But again, I'm going to show you the choreography of soils that move across this area every year and that have been doing so for quite some time. So when I say that this is a hyper-engineered landscape, what I mean by that is imagine I take the Ganges River basin that you can see here, and I just tip it 45 degrees. So you can see that the gray here is the basin itself, and then these tones of violet are the different large-scale rivers. Now imagine then I take and I look at it in terms of its layers. So I look at its rain-fed agriculture, which I'm able to get from satellite imagery and various GIS data sets. You can see here the rain-fed agriculture, and then you see here the irrigated agriculture. All of that black there is like a hydrological supersurface, which is to say there's no other part of the planet that has that level of irrigated agriculture. The Indus River Basin is the closest, the Yellow River Basin to some extent. And in the book, I do comparative work, but suffice it to say that this is the most hyper-engineered landscape on the planet. And so obviously then these canals and these bore wells that I'll share with you, they're not just supporting agriculture, they support people living in cities and towns as well. So there's a great deal of contestation over water infrastructure, but also I would say quite a bit of confluence of interests as well, that again, I'll share with you. And this term Ganges water machine, it's not mine. It actually comes from a transnational partnership that was done in the 1970s between a professor of civil engineering at the Indian Institute of Technology in Kanpur, Professor V. Lakshminarayana, and done in collaboration with Roger Reve, who was a professor of population studies at Harvard University. And they published this piece in 1975 that said, Ganges water machine, it's the most underutilized but great water machine of planet Earth, because they thought of it almost as what Richard White would call an organic machine. They really understood the monsoons as being part of this larger organic machine of groundwater recharge every year, as well as water for agriculture and water that's shed annually because of the not just the monsoons, but the incredible amounts of sediment that come down from the Himalayas every year. Now, they never in any way spatialize what this area looks like in the transformation. They, of course, produce formulas, equations. And so my job was, how do you spatialize? How do we do a kind of spatial history, kind of retrieval? So that required a certain kind of sleuthing in the work that I did. And so when I and they describe it as a machine, I'm not speaking about, say, like a marine chronometer, like you see here, like a well-oiled mechanical machine. Instead, what I'm speaking about is something that's more akin to like the auto-destructive art of the 1960s, where this is not a machine that's working perfectly with itself. It's kind of fighting oftentimes in terms of its groundwater infrastructures versus surface water. Or another way to put it, it's something like Luke Skywalker's bionic arm in The Empire Strikes Back. It's a biology with a technology, or it's a technology with a biology, right? It's a kind of cyborg. And so I try to look at the river basin through these different lenses to bring all of these different layers together. And so again, today, I will primarily focus on that kind of organic and inorganic alluvium that's shed every year. In the book, I look really at these two kind of extremes in terms of the spectrum of infrastructure, the canal system and the tube well system. Canal system is essentially building artificial rivers from existing rivers, right? We're kind of siphoning off. It's like a giant interstate system. They're very monumental, right? You can fly over them. They're very legible, to use a term from, say, James Scott's Sing Like a State. The tube well is almost the exact inverse. It is like a straw that you burrow down into the ground, you drill, you put a pipe, usually with a filter at the end of it, or at the tip of it, then you attach a mechanical pump and you can drop groundwater. It's a highly decentralized system that is sometimes powered by electricity, sometimes by diesel, and even sometimes by the human motor in terms of kind of almost like bicycle pump pulling the water up. But these are kind of like the two extremes, and they have these infrastructural vocabularies are very much also attached to the history, both politically and environmentally, of the basin. So a kind of pocket history of it very quickly is that this became a laboratory in the 19th and 20th centuries for building a new culture around water management. So the East India Company, operating in in the larger Bay of Bengal region in what is today West Bengal and Bangladesh. They keep moving further and further up the Ganges River basin through the kind of crumbling Mughal empire of its satrapies and principalities. And they keep noticing that as they keep going further and further upriver, famines are occurring. So the response is not that there's some kind of colonialism, imperialism, kind of imposition that's causing these famines, right? The scarcity of food, but it's because the region is so tied to the monsoons. So the answer is to build what becomes the largest canal system in the world to centralize water in order to redistribute it across the basin. So through a series of levers to do this. And so it becomes a kind of almost highway for water of the Ganges canal system. Now, the British East India Company had no experience in canal systems for irrigation. They only had it for transportation or navigation. So there was a lot of testing that was being done. They looked at the Mughal Empire in terms of its canal systems, as well as travel to the River Po in Italy, but there was nothing at the scale of this system that they sought to build. And so they ended up having to build the largest aqueduct in the world, longer than anything that the Romans had done, in order to cross over some of the rows or these rivers that surge during the monsoons, like you see here, the Solani Aqueduct in Roorkee. And they built this all the way from Haridwar, which is right here, where the Ganges River is said to make its great debouche, or this kind of entry into the Gangetic Plains. It's right at the edge of the Siwalik Hills. And they built the canal running almost parallel to the Ganges. Here's the canal system. Here's the Ganges to the north and the Yamuna to the right, through this area that's called the Ganga Jamuna Doab. Doab means land between two rivers in Persian. It's a kind of interfluve. So they built it all the way initially to the city of Kanpur. So almost kind of 2/3 of the way down this tongue-shaped interfluve. And eventually it grew to being over 12,000 kilometers long, being the longest canal system in the world. So this is a drawing of that evolution. There were copycat projects all over the world. The people from the United States, Australia, France, Britain would travel into British India to study these canals in order to try to do copycat projects in various parts of the world. So it became a kind of model, almost like a model organism to emulate or reproduce in other parts of the world. And in the book, I really focus on one of the things that really flummoxed the East India Company, the Raj, and then certainly later the nation state of India, is all of that sediment that's coming down. So here what you can see is what we would call like an overpass or a flyover, or what was termed at the time in the 19th century a super passage for a river to pass over the canal so that all of its sediment wouldn't get into the canal and clog it. And you can even see here styrofoam and various kind of organic material that's starting to collect here in the canal. And maybe you can see it even better here. You see all of that silt and sediment, that alluvium that's coming from the Himalayas, and then you see the canal passing beneath it. So there was a kind of gymnastics of moving the canal system through this area to try to thwart all of that sediment, boulders, trees that would come into this area. And all of that debris would start to tear away at the bed of the canal system. This is its reconstruction with the World Bank loan that happened in the late 20th century to rebuild it, because it also requires quite a bit of maintenance. And again, I won't go into that today, other than to say the maintenance of this project was quite huge. At the peak of it being built, it was employing 50,000 men, women, and children to build the Ganges canal system. So there's an incredible history of labor that is to be told there. But I set all of that up to say that the monsoons are really such an important part, a kind of almost architect of this larger landscape. If I had to do a kind of pocket explanation of the monsoons, which obviously I won't do justice to it, but suffice it to say, those vapors that I told you that fellow James Rennell was describing from the late 18th century, these vapors are produced because of a difference in temperature between the triangular shaped Asian subcontinent that you see here, and then those water bodies, the Arabian Sea, the Bay of Bengal, and larger Indian Ocean. And that difference in temperature produces those tempestuous monsoons every year, that kind of firewater cocktail that I mentioned that delivers between 1 meter and in some cases 29 meters of rainfall in a single year. So it's an incredible amount of precipitation, of course, that comes through here. And I'm interested in understanding, of course, that precipitation into what I mentioned to you before of sediment. So remember, I showed you that YouTube video of kind of the Indian subcontinent, the Asian subcontinent running into Asia 50 million years ago, crimping and crinkling up, producing the Himalayas. Well, these are a series of vertical sections. These red lines that you see here, it's like I'm cutting like a slice of cake through the earth, through Pakistan, Tibet, India, Nepal, Bangladesh. These red lines are then those section cuts, those cuts of the Earth's cake that you see arrayed here. And so I show you these because you can see just of how different the elevation changes between the Himalayas and then the Gangetic Plains. And they form this kind of uneven bowl where all of that sediment is being delivered over the course of 50 million years. So I'm cutting sections, vertical sections, slices through to understand the topography, but also, as I'm going to show you, to understand the relationship between topography and those monsoons, rainfall. So I take those 5 sections that I just shared with you that are cutting through, and I place them in relationship to one another, and then plot out the rainfall perpendicular to the section. So these kind of jagged red lines that you see here, it's showing the amount of precipitation over the course of a single year of the Earth orbiting the sun. So I'm literally cutting almost sections through rainfall. And I'm happy to talk more about that, but suffice it to say that I do that so I can understand the choreography of this area in terms of these rainfall patterns. So this is a drawing showing then 4 different times of the year, those rainfall patterns. And so I'm looking at precipitation in relationship to topography to better understand how those 2 things intersect with one another and their entanglements. And of course, you can see here all that rain that's happening here, that kind of monsoon. And I use then the equinoxes and the solstices as major points to understand, think of almost like the Earth as like this giant monsoon clock going about the sun. So here you can see in plan how the monsoons enter and exit the subcontinent, the tone of violet. And then here you see arrayed those 5 sections. So I'm also looking at how it moves both this way, so laterally, but also how it moves vertically as well, the monsoons. And again, I'm happy to chat more about this, but these are to give you some sense of just the kind of almost terrestrial and celestial scales I'm looking at in the work. All to say, because between 1 and 1.6 billion tons of silt are shed just within the Ganga Brahmaputra basin. To give you some sense of that, depending upon whether you count the 1 or 1.6 billion, that's between 2 and 3 times the amount of sediment that comes out, that's suspended in the Mississippi River basin. Now, the Mississippi is said to, depending on how you calculate, be the 2nd or 3rd longest river in the world. The Ganges barely makes it into the top 30. So there's just an incredible amount of silt that's being shed every year here from the Himalayas. And to give you some sense of that at a much more kind of specific, localized scale, I want to take you just for a moment to the city of Varanasi, which is roughly 700, well, I guess you could say almost 700 kilometers from the sea. So it's almost kind of tap dead center in the Ganges River basin. And these are a set of photographs I took in 2005 in October. And you can see there's not a cloud in the sky. It's just extremely humid. And yet you can see just in these 2 photographs how the water level is going up and down. Now, you'd think that we were coastal, but again, we're over 700 kilometers from the sea. And it's not just that the water is moving up and down. You can see the incredible amount of silt that's then deposited here every day as well. To give you some sense, now these are along the Ghats or the steppes in Varanasi that lead to the Ganga. But again, I show you this to see just the choreography of water, soil, and people are so imbricated with one another. And following the sediment can tell you a great deal and draw into focus so many different aspects of the river basin. And so my job was really to try to become something like an anablep, which is called like a four-eyed fish, right? Because it can see both like a human and a fish. Because, you know, when we go underwater as human beings, right, everything becomes quite murky. Well, an anablep has four sets of eyes so that it can see like a human and a fish. It kind of operates, right, in that space, or even better yet, because growing four eyes is kind of complicated. Think of it almost like, how do you become like a mud skipper? Which a mentor and dear friend of mine, Graham Burnett, informed me of, who's a historian of science, that the kind of mud skipper is able to actually adapt so that when it goes underwater, it sees like a fish, and when it's above water, it sees, right, like a human being, which is why it's oftentimes referred to as a fish that lives on land. So I wanted to be like a mud skipper in the sense of, how do I operate in this limical or mud-loving realm to engage this kind of muddy topography of this monsoonal landscape. And that silt then, when we start to reorient ourselves, that silt that's been coming down, right, for 50 million years, it creates what a hydrogeologist would call an incredible level of groundwater potential, which is all to say that that silt acts like a sponge that makes it a really fantastic place for drawing up groundwater. So it holds water very close to the surface of the soil in many parts, like you can see here, which is why the Ganga or the Ganges River Basin has the greatest groundwater potential, and why it's become kind of testing ground for tube-well infrastructure, that highly decentralized system. So I won't go into great detail about how the tube well works, other than suffice it to say, you drill down, as I mentioned before, attach a pump to that pipe, and then you can draw up groundwater. And it's an incredibly important resource. It's what makes India the largest consumer of groundwater in the world today. And again, I won't go into the history of it. I do so more in the book, but I certainly look at why, say, films of the films division of the Indian government in the 1960s and 70s would do things like this, where they show this lorry or this semi-truck coming to an ox-driven village to sink a tube well, the kind of amazing amounts of water that gush out. It's like the wet dream of development or nation building at this time, that it's on demand, and how it became such a critical infrastructure for what was called the Green Revolution, where here in this Punjab National Bank ad, I like very much, because in the foreground we have the Punjabi farmer with the high yield variety wheat from the Green Revolution, right, thrown over his right shoulder. We see a tube well operating here, DDT being sprayed, and in the background we have presumably the Ford motor tractor, kind of industrializing agriculture. But even though this kind of imagery persists, like this advertisement that one finds all throughout the basin, especially in UP, of a kind of idea of the farmer relying on this infrastructure, it's really also what so much of the urban population depends upon as well, because cities and municipalities are either unable to provide potable drinking water, or it's so unreliable or potentially even polluted that many people have to sink their own tube wells or hand pumps, like you see here. And so what the tube well does is it turns the ground into infrastructure. But this infrastructure is unevenly accessible. Not everybody has the means, in terms of capital or expertise in order to sink a tube well. And oftentimes they're hidden in a space like you see here, though you find hand pumps all throughout the basin, like here in that city of Kanpur that I was mentioning to you before, that becomes an incredibly important social and physical infrastructure. And I've written quite a bit about how then the Ganges water crisis is very much tied to urbanization and the tube well. And again, I won't go into great detail other than to say, as I'll mention at the end of the talk, public scholarship is a very important part of the work that I do in terms of trying to reach larger audiences. So the New York Times or the Indian Express, to give just two examples. But all of this work, and this is really where the meat of the rest of the talk will be, evolved in 2004 when I started this work. I was fresh out of undergraduate at the Rhode Island School of Design, and I knew I wanted to study a major river basin. So I looked at the Ganges, and at that time, the best books in the Anglophone world I could find were like Raghuber Singh's The Ganges, Madcap Adventures, like Slowly Down the Ganges by Eric Newby, where his wife divorces him at the end of the boat trip because it's such an awful trip, or the kind of irrigation projects in India, this kind of avalanche of statistics or history of cartography. And certainly also Kelly Alley's book on the Ganga as well. And I'll talk more about why I don't look at pollution so much in this work, which is how I probably got a Fulbright, because everyone the year that I applied for a Fulbright got denied a Fulbright fellowship to India if they were looking at issues of pollution. But so Google Earth, extremely low resolution, right? Like India actually claims that it compromises their national security in 2004 more than the state of Israel complained because of the legibility that it seemed to offer. So it was extremely low res, was not very useful. There were drones. I didn't have access to them. George Bush's administration was using them to, assassinate people and to do espionage, but I didn't have access to use them, so I didn't have drones. Gray satellite system, the level of resolution, it's since been decommissioned, but it's such low resolution that it would not have been very useful for me. So I wrote a Fulbright proposal to say, give me a year, I'll go to India and I'll use a Garmin eTrex GPS handheld unit like you see here, and an even clunkier Nikon camera. And what I said I would do is develop what I call the dynamic atlas, that I would develop new ways of visualizing this territory, how it changes with the monsoons, so almost like kind of cyclical sense of time and history, but also how it's evolved over time, so a kind of chronological one, right? 19th, 20th century, etc. And much to my surprise, I got the fellowship, though I thought it would take me a year. It took me a decade to finish the work. But when I got to India, I hoped I could find maps, but these were actually, the best maps I could find were actually from the 1960s and 70s, and they were oftentimes tracings of maps from the 1950s, and even sometimes even well into the 40s. So they were not very useful, and oftentimes I would be asked, do you work for the CIA, when I wanted to see maps? And of course, I didn't, nor do I expect somebody who did would. So I never got those maps. So I literally had to go out and be my own barefoot cartographer. I feel that this is especially funny to show you this kind of counterfeit Texas Longhorns hat that I bought near the Nepali border to shade myself, all to say that I had to be my own barefoot cartographer and hydrographer. I really had to go out and do this field work in order to make the kinds of drawings that I'm sharing with you today, and to do this kind of historical work and this cartographic work within the basin. So I went from the Gangotri Glacier, which is about 3,800 meters above sea level, through the Gangetic Plains, taking some 25,000 photographs of the entire basin. And the book ends at the city of Varanasi. It actually was supposed to go much further, but the book was supposed to be 200 pages. It came out to 400 pages. My publisher was ready to put my neck in the guillotine. So I had to stop the book there, but it's actually, the work is extended now all the way to Bangladesh. Now, I'm gonna really end the talk today with this city of Allahabad, or Prayagraj, which is this city at that tip of that interfluve, that doab that I mentioned to you before, that tongue-shaped land, where here you can see the Ganges River, the Ganga, the Yamuna or Jamuna River here, the city of Allahabad or Prayag, and then where another river is said to meet the Saraswati. Now, this is supposed to be one of the most sacred sites within Hinduism at the tip of this interfluve. And it's been studied quite a bit by geologists like Indra Bir Singh, who sadly just passed away last month, who looked quite a bit at studying the sandbars within the channel and doing these kinds of stratigraphy and documenting of the area in terms of its geology. And of course, doesn't write too much about these things that we call human beings walking around here, but I'm going to show you how I start to incorporate humans and the kind of practices and the mark making that they leave in this site in just a moment. But the best maps, absolutely the best maps I could find of this area, were what are called calendar art, which are these images that one can collect that change every year across many sacred Hindu sites within India. And I find these drawings fantastic because they relate the celestial and the terrestrial together. And what I mean by that is that we can see here Ganga, Jamuna or Yamuna, Saraswati, these three goddesses, right, coming together at the Triveni Sangam, but we also see the rail line, we see the South Indian temple, a mosque and fort built by Akbar, Mughal emperor, a church. There's a kind of bringing together of the terrestrial and the celestial, and certainly also again here in terms of people bathing at the confluence of these two rivers, drawn here in terms of kind of turquoise and cerulean blue. And in fact, when you go to it, and I hope you can see this on your screen, you see these blue waters of the Yamuna, kind of azure waters, and the brown-gray rivers of the Ganges meet. And it's that line that's constantly in a state of flux that is the most sacred site within Hinduism. And for me, this is not just the meeting of two waters. Actually, more importantly, it's the meeting of different geological provinces. So all of those tectonic crumbs that I mentioned to you, they're all coming together right here, and of course, being distributed throughout the larger basin. And so this is, for me, a kind of microcosm of what happens all throughout the basin. And so I did these drawings, which were not tracings of the city, but I had to do my own cartography because there were no maps. So I did both kind of cartographic plan drawings, like looking from above to the left, and I did photography, like you can see to the right, combining cartography and photography in order to produce this dynamic atlas. So these tones of violet that you see on the right, it's how the Ganges and the Yamuna rivers expand and contract and all of the other surface water bodies. And that expansion and contraction, both horizontally and vertically, is the result of the incredible amounts of sediment that come especially from the Himalayan-fed Ganga, and to a lesser extent with the Jamuna or Yamuna River to the right, because even though it starts in the Himalayas, it's mostly fed by the Chambal River, which is coming from the Vindhya mountain range. So these tones of violet, they're different moments in relationship to the solstices and equinoxes. So imagine that I draw that ellipse of the Earth orbiting the sun, and we see those incredibly important points of solstices and equinoxes. Now imagine I take that ellipse and I straighten it, like you see here. Those tones of violet happen in relationship to the equinoxes and the solstices. And what that allows me to do then is I draw all of those things together, kind of bringing all of those layers together to draw this area. So if I take it apart in layers, say this is how I was able to map and draw it in April, in May, in June, August, September. Then I draw all of the rivers. I draw all of the settlement that exists here. I draw all of the roadways. And then I bring all of those layers back together to see how they're entangled, how they're co-authoring and shaping space. And you'll see that there's quite a bit of urban density here versus a lot less up here. And that's because historically, the Jamuna River is an incised river. So the riverbed shifts very little, but you can see how much the Ganga moves quite a bit. So it also not only has ramifications in terms of its urban form, what an architect would almost call its urbanism, but also in terms of its urbanity or how people live within this area. And so I also then would go to the Sangam every week or every other week for a full year to photograph it. So this site is where every year during the month of Magh, a Magh Mela takes place, January, February, so it's just ending, where between 4 and 5 million people come to bathe at that confluence and where a temporary city is constructed. And this temporary city, it has electricity lines, plumbing, etc. And you can see when the time of that festival is right here in terms of that tone of violet. And so what I would do is I'd go to the Sangam and I would do this panorama. So I'd stand the exact same place every other week for a full year to photograph it. And then I would draw it from up above, like a satellite image or a plan view in terms of its cultivated lands, its roadways, settlement patterns, population density, and a kind of summation. And so this town, after the festival is over, this incredibly densely populated urban area, it goes from this to this. The grid of the city remains, even though all of the tents have been pulled up, even though all of the temporary roads and the plumbing are taken out, farmers move in and they use the grid of the city that's left imprinted on the soil for agriculture. It is the most intelligent use of space that I have ever witnessed in my life. And of course, all of this sediment is being shed from the Himalayas every year. They start to harvest their crops, these farmers, the monsoons, right? They start to flood and wash it all away and completely take it over. And this happens every year. And so these drawings are, as I understand it, the first kind of drawn and written descriptions of this slow motion change. So I use the tools of architecture and geography to capture slow motion changes that are happening here, as opposed to trying to capture change that happens oftentimes at the speed of a news cycle. So it's a kind of slow motion change taking shape here. And so this is then bringing together all of those cartographic and photographic drawings together to get a better sense of the kind of urbanity and urbanism, but also certainly the larger dynamics, both at a kind of social and urban level, and certainly also even at the scale of the soils. And much to my surprise, this drawing has now been kind of cited in as part of UN studies of how to draw the kind of sacred geographies and biophysical layers of a city, not as something that's static, but as something that's dynamic. And so this drawing then that I would say, the drawings that I do, they're much more, if you think about them in fashion terms, they're not so much like couture, like Givenchy or Dior. They're more like ready to wear, like something you get at H&M or Big Bazaar or Zara. You gain a few pounds, lose a few pounds, it still fits. It's what's called a seam allowance in apparel design. So the drawings that I make are for expanding and contracting so that they don't become kind of stale or outdated before they're even done, because of course this area is changing dramatically. So that drives the work that I do. And then, of course, these are photographs from the large full picture or Kumbh Mela that happens here every 12 to 13 years, although it's been happening now more often, where you can see these pontoon bridges built across the silt and sediment that's built up in the Ganges River Basin. This is that photo that I began with, where we see these bundles or these temporary structures built out of bamboo and covered in either canvas or metal and painted, where very large events are taking place during the Kumbh, where for 45 days, it's estimated between 80 and 100 million people pass through this area, becoming, as is oftentimes said, the largest gathering of humanity on the planet. So here you can see these photos I took in 2013, hanging off the side of a permanent bridge to photograph it. It's inhabited 24 hours a day. But what I would say is more amazing than this photo that you see here is that in 2 weeks, it goes from this to this. Farmers, as I was mentioning before, right, they use the former grid of the city. The water table level is so high because of all that sediment, right? It's like a sponge that you can easily irrigate crops. You can see the avenues and the roads then forming the kind of basis for this agriculture. You can see the footprints of the tents and of the roads kind of tattooed into the sediment. It's literally a drawing at the scale of the territory. And then, of course, it gets washed away every year. So it's like a giant Etch-a-Sketch. It kind of gets bounced around and then has to be redrawn. And again, I think it's an incredibly intelligent use of space that builds upon the dynamics of this river basin rather than trying to fight them. It's a kind of choreography that's much more about making the most of these dynamic conditions. And of course, it's not just a space of agriculture and religious festivals, it's also a space of recreation. You can see here all of these water buffalo wallas bringing their water buffaloes. We see pujas that have been happening, a bazaar, people bathing. It's an incredible urban mixed use space. And all that sand also that's being shed from the Himalayas is being then illegally extracted oftentimes for the concrete industry in this area. So many of the houses are actually built from sand that come from the Himalayas. So again, trying to expand the notion of what constitutes the Himalayas. So much of the architecture actually in this area, especially new construction, is built from it. And I take this kind of technique of drawing and I apply it to the transect, or what Alexander von Humboldt would have called a kind of, I don't speak German, but kind of Naturgemälde, of a kind of swath of land going from ridgeline to shoreline, like you see here, as a technique that's used oftentimes for drawing different ecologies and elevation. And kind of Alexander von Humboldt developed this when going to South America, this incredibly, I think, rich drawing, because we have both textual descriptions of all the instruments and the kind of mosquitoes that were biting Alexander von Humboldt as moving through the basin. We see both kind of the Atlantic and the Pacific on either side, and this kind of Chimborazo, right, Avenue of the Volcanoes, and drawing and plan. There's a bringing together of all these different layers of information. And so von Humboldt uses this technique to develop a different way of understanding, of course, isotherms and other aspects that we talk about so much in the history of science. But suffice it to say, he's looking at geology and the environment that then becomes the basis for doing a lot of comparative work in the 19th century of, say, why is it that the Himalayas and the Andes, like you can see here, the different kinds of vegetation and geology. So bringing together the vegetal and mineral kingdoms together, which is quite important in the 19th century. And even here in this drawing of this physical atlas, you see the vegetal, the mineral, and the animal kingdom all coming together in this set of drawings of using the transect. And for us, what's really important is that it comes together, especially with Patrick Geddes in the Valley section. Geddes, Scottish biologist, who actually does a lot of work in British India in the 19th, 20th centuries, of this idea of the Valley section of, again, going from ridgeline to shoreline, but looking at the different kinds of occupation or labor that take place. So not understanding nature and culture as being in opposition, but actually how they are being braided together, a kind of co-authorship of space. And this becomes incredibly important, not just as an analytical tool of understanding the environment, but by the late 1960s, the landscape architect Ian McHarg starts to use it as a way to be projective, as a way to bring the different layers of the built environment and natural environment, right, in scare quotes, together. I use this technique of the transect to then map these areas of the Ganges River Basin. These transects are these swaths of land, so that I don't understand the river basin as being just two parallel lines, but instead these larger watersheds. So you see these tones of violet that probably look recognizable from that drawing of Allahabad. Well, I do the same thing for these transects. And so I'm going to show you very quickly when these transects, you can see the water bodies in terms of the supposed rivers, all of the roadways that exist in those six, the settlement. And again, this took me a long time because I had to do all of this by foot because I didn't have any satellite imagery. You can see all the surface water bodies, and you can see all of the drains and canals and nalas. Now, if you notice here, there's a lot of surface water bodies here, very few here, but look at the settlement. It's quite even here, diffuse in here, and that's because all of these areas here, as well as many of the areas over here, they depend on the tube well for drawing up groundwater. So again, all of that sediment that's been distributed. So I take all of those layers, and like with the drawing of Allahabad, I bring them all together again to show those kinds of entanglements. And so these drawings, again, they're more like ready to wear and less like couture. And so I can then even zoom in further with the transect to start to look at the water body in section and in plan. I can even use it to start looking at different cropping patterns in different areas. So it can really allow me to not only zoom, but also pan across different parts of the basin. And in the book, I explore different ways of drawing all of this. Now, I did all of this because I had to make my own instruments and prosthetics that Professor Lee had mentioned to you before. And so these are these instruments that I would wear, like the surface accumulation sleeve, which is literally a prosthetic that I would wear over my right arm, that you can see then has that clunky Garmin E-Trex. It has packaging tape attached to it that I'll share with you in a moment, and even a space back then for my clunky Nokia mobile phone. And I would use then the GPS to help me triangulate where I was at on the surface of the earth. And then that packaging tape, I would go a kilometer perpendicular to the river edge or to the channel edge, like you see here, patting down that packaging tape to pick up the surface, the particles of the soil. And I do that because particle sizes can tell you a lot about the behavior of a river basin. And so you can almost think of it as like Spider-Man, right? The web shoots from his wrist. Here, I'm shooting packaging tape from my arm. And so this is an example of a kind of 2.0 version of using a ski guard, a packaging tape dispenser, and attaching it in order to do this work. And so here's a kind of a a little vignette or a diorama of the way that that works from an exhibition I did at the Seoul Architecture Biennial in 2019. Where hopefully here you can see, these are figurines from the TV show The Walking Dead. This is a example of somebody wearing the surface accumulation sleeve, right, taking a reading of the basin, again, kind of Spider-Man in reverse. And a colleague who teaches in Tokyo, Catherine Hansen, said it reminded her very much of Katamari Damacy, which is a Nintendo game that was developed by Takahashi in 2003, which is about this prince of the clumps, essentially. And it's a kind of clumping technology. And the reason that Catherine said this reminded her of this video game is because you have this little prince who goes out into the world and visits Earth to try to build new cosmos. So he has this ball that then different things start to stick to, like you can see here, a spoon, darts, scissors, but it keeps growing, jungle gyms, right, until it becomes the size of a city and even a star to build new galaxies. And so the work that I did is not just that I'm picking up soil. I start to pick up so many other things, marigolds, petrified human fecal matter, car parts, plastic parts. And so it brings together different forms of human occupation within those rolls of tape. And so I developed this instrument that I call the surface accumulation reader, which is where I took parts of a bicycle and repurposed it so I could put these very large rolls of tape, right, with all that stuff stuck on them, and then literally crank or move like if you're cycling on a bicycle across 4 different parts of the basin all at the same time. And so this is an example of how that technology, another diorama of working between the space of a lab and doing field work. So here, I don't know if you can see it so well, there's that kind of little instrument with the tape, again, with the Walking Dead figurines. So this exhibition about trying to engage that. And I scanned all of these several hundred kilometers of packaging tape with soil, and I used the wrong thing for the right purpose. So I didn't have access to very sophisticated technology, so I used the magic wand tool in Photoshop, which magic wand tool you might use to do something like this, right? You want to, say, put a tattoo on a breastplate. So you use it in order to get rid of most of that white. Well, I misuse the magic wand tool to actually break down the different particle sizes so that I can start to do particle analysis of the basin to have a better sense of its behaviors. And of course, I use this not only in the kind of biophysical way of doing it, but also certainly in being able to tell a very different story of inhabitation. And so then this is an example of that again from Seoul. And I then would 3D print these different portions of the tape to give you a sense of just the different textures and soils. So I'm working from 3D to 2D to back into 3D. So there's a kind of synthesis that's happening throughout the process. And the last technology that I made, which was the Ganga Dip Sock, I bought 100 pairs of pristine white Minnie and Mickey Mouse tube socks to then thrust into the basin in order to collect soils. So as another means of collecting this, with the idea that if I got stopped with trying to bring in soils, say into somewhere that, why do you have all of these 100 pairs of socks, that I would just say I was a filthy backpacker that didn't have time to do my laundry, as a means to bring these in to do another form of kind of analysis and way of narrating these spaces. And so here again is a kind of diorama of the process of doing the sock, drawing it out like it's on a clothesline, again, in order to engage a larger public. But I use all of these techniques to make these drawings. So using, again, the wrong thing for the right purpose. And that's then gone on to retrofitting remote control cars to make them into rovers, kind of this surface accumulation rover, like you see here, that I made so that you don't have to do the backbreaking work of collecting soils, using the Nikon camera, the 3M tape, etc. And again, here's a kind of diorama of that from Seoul. And exhibitions are such an important part of the work that I do. This was a set of exhibitions that were sponsored by the Ford Foundation that I did in conjunction with Columbia Global Centers when I taught at Columbia University, and in particular with Dr. Ravina Agarwal, who's the director of the Columbia Global Center in Mumbai. So these were a set of exhibitions at a science museum where I try to, again, engage a larger public with the drawings that I make, They're quite illuminated from behind, so they have a kind of glow to them. Physical models, which have projections on them of kind of the evolution of tube wells, along with a video then that you can see here of the descent of the Ganga across this area, so that people can watch and understand these kind of larger geological processes along with the kind of cultural and political conditions of it. Exhibitions like this, where I do these kinds of performances and walk through, where you see these three mannequins that have my soiled sock on, surface accumulation sleeve, etc., to engage larger publics with the work that I do, along with physical models. And here, these images from Seoul of creating transparencies on an overhead projector so that people can build their own images and models of the basin over time. And I show you all of these to give you a sense of the different scales at which I try to work in terms of the sediment, from the soil structures to the GPS, to the kind of urban conditions, all the way to the regional, and I hope also in some ways to a global scale of tracking sediment. And I do all of this through both the Ganges Water Machine book, through op-eds that I've written, and through exhibitions and workshops, because I think it's very important to engage different publics, not just in the academy, but outside of it, because I think that you can be brilliant in what you do, but if you don't have a means of sharing it with people, you're going to lead a very lonely revolution. And so for me, the work that I do is very much tied to engaging different publics, because otherwise I think we'll continue, especially in a basin like this, where we can learn so much that I think other parts of the world can benefit from, and not just within the larger Himalayan region. I think we'll still suffer the effects of sight without the advantages of insight. So thank you very much.
Thank you so much for, these final words of not leading a lonely revolution. So we do have the Q&A box is open. I think, Amber, we also should have the raise hand function in case if you can't see the Q&A box. But for if there are any questions from the participants, please raise your hand or post your questions in the Q&A box. So while we wait for your questions, Anthony, can I start off and ask a little bit about? There's so many things that you're inviting us to think about, and I kind of wanted to ask about your work on New Orleans and other I guess on other kinds of water beds. And you mentioned Houston as a site. And one of my very uninformed questions is the difference between a monsoon and a hurricane. So can you tell us a little bit about how your work on other rivers and other basins has built on your work on the Ganga?
Definitely. I lived in New Orleans for a time, and I have family that lived there. And I also kind of developed this romance for rivers and cities along the Tiber in Rome as well. And I would say that that is in many ways what brought me to looking at the Ganga or the Ganges, because I found that there were oftentimes such long histories of, especially with the Army Corps of Engineers and even with the Roman Empire, of ways of dealing with the dynamism of rivers. And I was particularly interested in the history of the Army Corps of Engineers and its work on the Ganges and how that's been exported. Certainly there's the Mekong River Commission, which is actually modeled on the Mississippi River Commission. So there's joint projects between the Mekong Basin and the Army Corps of Engineers. And I was interested in looking at a river basin that I didn't realize was so hyper-engineered as the Ganges, but engineered in a very different way from the Mississippi. And actually, when I went to India as a Fulbright Fellow in 2005, it was just after Katrina. And so I was giving a talk at a museum where I had exhibited some of my work, and some people asked, well, what are you doing here studying this when it seems that like New Orleans is completely underwater in such dire straits? And my kind of just off the cuff answer was, well, I'm very interested in studying how for so long people here have incorporated the dynamism of rivers and the larger river basin. into daily life, and what there might be to be learned and gleaned from that. And as an architect at the time, before I'd become a historian of science, I said I'm just very fascinated in understanding how people negotiate these conditions. And so in that way, New Orleans still figures prominently, I think, in the work that I do, in the sense of what brought me to the Ganga, and certainly in my teaching at Yale, as you know quite well, because I've had you there for reviews. I teach a course where students explore New Orleans' kind of limical or mud-loving realm through its infrastructure to understand the histories of colonialism, enslavement, infrastructure more generally, environmental uncertainty. So it still figures prominently in the work that I do, which again was why I was so keen to come to Houston, amongst many other reasons.
Yeah, no, thank you so much. We have two questions. One from Kamala Visweswaran. Kamala, I'll unmute your mic, and then we have another question from Louine. So Kamala, I think your mic should be unmuted if you want to ask your question, and then we'll have Louine following up.
Yeah, can you hear me?
Yeah.
Yes.
Yeah, so thank you for your presentation. It's a really thought-provoking and interesting project. And I wanted to ask you to say a little bit more about the problem of silt. And I want to say I haven't yet had the chance to read your book. I've been wanting to for a while, but so you may have dealt with this already in your book, is what I'm saying. But it does occur to me that the problem of silt is one that occurs when you think about, say, water management and large dam management, because siltation is an issue for big dams anywhere in the world. But, you know, what is a problem for one field is actually, you know, the thing that is a gift for another field of study. So in archaeology, you know, the Indo-Gangetic plains and its siltation and resiltation is simply the basis for the founding of a civilization. And I think also if you look at, you know, the siltation process in Bangladesh, where farmers are really used to, you know, the flooding and receding cycles of the monsoon, and building a farming cycle into that, that's also there. So partly, I guess I'm wondering whether I want to hear more about your curiosity around silt and deposition as something that almost appears as a problem that needs to be solved or addressed through mapping. And I guess the related question has to do with pollution, which you don't you know, address directly, but it seems like you've done some popular writing about that. And you're probably familiar with Sudipto Sen's recent book on the Ganga. And one of the things he helped me understand was that, yes, of course, the problem of pollution is relative, but vis-a-vis the Ganges, for many devout Hindus, you know, it's a river that can never be polluted. And he helped me understand, like, its cleansing and purifying properties, and how that becomes a knowledge system that isn't necessarily something that is contested by science, but something that, you know, is maybe another layer of sedimentation to deal with, in terms of how one thinks about sacred geography, sacred knowledges, and also slow knowledge. And I guess, you know, just as in appreciation, I think you and Sudipto Sen have both been engaged in slow knowledge projects, which are very different. Yours took 10 years, and I think, you know, Sudipto Sen also took about 10 years or longer to finish his book on the Ganga. So any part of those reflections, I'd be interested in hearing you say more on.
Well, thank you so much for it's a fantastic question, a set of questions. I definitely, in the book, I look at how one of the things that really, one of the reasons that up until the East India Company, a kind of a perennial canal, or a kind of a consistent year-round canal system hadn't been built along the Ganga was because of the amount of silt that came down from the Himalayas, and also because of the topography. So the East India Company really had the hubris to think that this was possible, and made a lot of mistakes with it in terms of just its construction. But silt and boulders and kind of just detritus in general, as it would be framed then, spoken about, became a huge problem in terms of clogging the system, of tearing up the canal structure, which still really thwarts the canal system to this day. But it's also what led to the first school of engineering in the British Empire. Actually, East India Company India had a school of engineering, a formal one, before one was actually in Great Britain, and it was precisely to train the colonial subjects on how to manage this system. So there's a very long kind of history, and I go into it in terms of what becomes IIT Roorkee in the book, about the way in which engineering as a formal institution happens, particularly around the conditions of water management or building this artificial river. And this certainly kind of silt, as you so nicely put it, for some is a problem and others is a boon. And I think the different kinds of not just hydrological regimes, but energy regimes, and the different kind of water energy nexus that develops from that, from say the Terry Dam system for hydroelectricity versus the Ganges Canal system for rerouting water, but also ultimately sediment drastically changes the topography, the geomorphology, and certainly also kind of the on the ground lived experiences of farmers who depend upon that silt or that water in order for irrigation, especially along the edges of the water channel. So I try to look at different, in the book, I look at these different almost kind of spectrums or kind of what some have called hydro mentalities of the river basin with respect to its silt. And then I also look at then not just that kind of engineering works, but also the kind of delicate choreography that I showed you that happens at Allahabad or at the Triveni Sangam, where obviously it's not coastal or even remotely close like Bangladesh is to the larger dynamics of the Bay of Bengal, but still takes a kind of slow motion development, and how do you of using those sandbars and shoals to build, I think, a temporary colossal community that then gets disbanded and made into agriculture. So that kind of almost using the wrong thing for the right purpose there is something that I explore quite a bit in the book. And then with respect to pollution, definitely kind of Sen's work, I would also say Kelly Alley's work too, on looking at that difference between the how for so many Hindus the Ganga can never be polluted, even if it is in the kind of public health biophysical sense of it, and understanding those dynamics. I think for me, because of the history of, say, the Ganga Action Plan that was done, was in 1986 spearheaded by Rajiv Gandhi. My attitude has been in terms of not so much the historical side, but more in terms of the works of the government, that focusing on the pollution has not led to very many successful outcomes in terms of the desired results of these sewage treatment plants, Ganga Action Plan. And mine has been to really look at the infrastructure and to think about how infrastructure starts to draw, conditions of pollution and purity into focus in a slightly different way, say with the Ganges Canal, that there were a lot of Brahmins, especially in the late 19th, early 20th century, protesting the Ganges headworks as a way of fighting colonial and imperial occupation of the subcontinent. So I look at how those also become sites of contestation for, I think, a different imaginary of the nation state, and certainly also the ways in which even today that's used, I think, for a very specific discourse in India, right? In terms of, I would say, especially with the current political situation in India. I oftentimes say, I think the reason that I was able to get research visas all of these years is because I never focused on pollution directly in my work. And I think there's really great scholarship that already does it. But everybody that I knew after 2005 for quite some time just wasn't able to go. So that also probably shaped a little bit my rationale. That was, I'm terribly sorry for what was an incredibly good question. It turned into a very long one. Long
Thank
answer.
You so much. Laureen, do you mind if I'm gonna invite you to ask your question live if you like. I've just asked you invite. Okay, great. Laureen, are you able to unmute your mic? Or okay, perfect.
Can you hear me now?
Yes.
Yes.
Perfect. Yeah, thanks so much for this incredibly fascinating talk. That was super enlightening, and I really enjoyed the methodological toolkits and inventiveness of your talk, and all the just like talking about the history of your book project and all of this, which came to it. I was particularly fascinated with the images and maps you showed of the Kumbh Mela pop-up city, and how you shifted back and forth between these horizontal panoramas and vertical mappings. And I wanted to ask you about maybe speaking a bit more about the blind spots and respective advantages of these different methodological perspectives, and or to say, how did photography help you to draw these maps, or how the maps changed the way you did the photographies here. And as an additional question, I was also wondering whether you encountered any archival material on the history of these festivals and the river basin, and how how the British colonial presence, what role did the British play in shaping these festivals in particular?
Thank you for the not only kind of kind compliment about the work and also for these great questions. I mean, I knew in doing this work that I wanted to do drawings that would not be outdated before they were even done. So I was very interested in the subjectivity of measure in the work that I do. And I mean, I didn't talk about that in this talk, but the instruments that I make, I think, very much engage with this subjectivity of measure. And you know, there's a great project. I didn't show it in the talk, but the French artist Marcel Duchamp in 1913-14, very kind of Dadaist, kind of moving into what would have eventually become much later surrealism, but did this beautiful project called Three Stoppages, which was where Duchamp, who was very interested in canned chants, was interested in taking something that was a kind of ready-made, like the meter stick, right? That seemed fixed. It's this hard rod. It doesn't matter where you go on the earth. It's always the same length. And what he did was he took the meter and took a piece of string that was a meter long, held it a meter above a surface and dropped it 3 times. And it made these 3 different squiggles. And by changing the materiality of the meter, he showed that you could have an infinite number of meters and that all of those meters were all the same length, but also quite different. And so playing with that kind of subjectivity of measure. The work then that I do, and I think that's why I kind of invoke things like, say, apparel design and fashion, is how do you make things that have a certain seam allowance or that are flexible in the work that I do? And that definitely, I mean, I'm not showing you kind of back of the house all of the failed attempts at that, which there were many. But I think that combining photography and cartography was a way for me to not try to draw everything, but to instead layer and find where things intersect. So where are there contestations? But I think also maybe sometimes that in the academy we don't always see so much. But also confluences. So where are there things that are actually coming together and seemingly working? with one another. And for me, the Sangam is an example of both those contestations, but also these incredible confluences, not to be too literal about it. And I mean, blind spots, I think that there's any number of them that occur. Of course, I want to say there are absolutely none. It's like, watertight, to keep using really bad water puns. But it's all to say that I think that there are certain things that get lost, but there are certain things that I think that if I had more space, I would have included much more of the kind of ethnographic work that I did of engaging with human subjects and speaking with them. But I think there's also a certain amount that I'm able to capture, I hope, in drawing that words and numbers don't, I think, also give a sense of. So I was really operating a little bit like a sleuth, a little bit like that beautiful Carlo Ginzburg text from 1980 on Sherlock Holmes, Morelli, and Freud, where I'm looking for artifacts or clues to build a larger story, and recognizing that, as all of us humanists and social scientists know all too well, we can't build the thing in full, or we can't reconstruct something in full. We're trying to retrieve, and that those are obviously, they're fragments, but how to tell a story through the evidence I'm able to collect, and the struggle always is how to bring some level of coherence to it as well, because it can really seem not to be the case. But I think that, I hope that kind of speaks to me acknowledging to some extent the blind spots, which I'm confident there are quite a few, but I also hope what are some of the advantages to do this kind of work, of having to go out and work between field work, which then brings me to the lab work, or the kind of archival. So in the book, I have lots of archival images and documents that I cite in terms of the Ganges Canal system, in terms of the development of Magh Mela and Kumbh Mela. There's texts that we have from Imperial China from the 8th and 9th century of people coming to this site and visiting it. We have texts certainly also that come from the Greeks in terms of visiting some of these sites, and certainly the texts from the Mughal Empire and even previous ones. So I draw upon a lot of those, and certainly also the patras, or the kind of cadastral maps that are left over from the that are primarily written in Urdu, that I looked through quite a bit to do the archival work of the land records of these areas. So there's a lot of archival stuff that I didn't share with you today, but there's a wealth of it, I can assure you, in the book, in terms of the records that I rely upon to do the work.
Great. Thank you so much. Thank you, Loheen, for your question. Thanks also, Kamala, for your questions. If you have any other additional questions, feel free to reach out to Dr. Anthony Acciavatti. Anthony, do you mind putting your email in the chat if people want to reach out? Thank you so much again for your talk. I know that we are a little over time, but what you've introduced us to think about sedimentation, precipitation, land, sky, celestial, terrestrial, not that these are all binaries that we work through, but that these are just spaces to think in and to think across. And thanks also for, this incredibly, probably very, very tedious project that you've ever undertaken. I don't know if I would ever take on something this of this scale ever in my life. So thank you for sharing with us this this project that you've really put your lifeblood in. I don't know how many calluses you've gotten from wearing tube socks full of rocks. So thank you, really thank you so much. And please join me again in thanking Dr. Anthony Acciavatti. Thank you for taking the time, and hope to see you at the next Transnational Asia Speaker Series. Thanks, Anthony.
Thank you so much, Professor Lee. I really appreciate it. It was wonderful to be here with all of you today.